everyone, in this video, I'm going to demonstrate an interactive Shiny application built in R that helps us understand one of the most important results in statistics, the Central Limit Theorem. The Central Limit Theorem states that regardless of the original population distribution, the distribution of the sample mean tends to become approximately normal as the sample size increases. This is a foundational concept in statistical inference, but it is often difficult to fully understand from equations alone. This app is designed to make this idea visual and intuitive. Now, let me explain the motivation behind this application. In many real-world situations, data do not follow a normal distribution. They may be skewed, discrete, or even highly irregular. However, when we repeatedly take samples and compute their means, a remarkable pattern emerges. The sampling distribution of the mean becomes approximately normal. This is exactly what we explore in this simulation. Now let's go through the interface. On the left panel, we can select the type of population distribution, such as exponential, gamma, normal, Poisson, or uniform. For each distribution, we can also specify the relative parameters such as mean, variance, or rate, depending on the case. We also control two important settings: the sample size and the number of repeated samples. These parameters allow us to observe how the sampling distribution changes under different conditions. On the right side, we have two visual outputs. This first plot shows the population distribution based on the selected model. This helps us understand the shape of the original data, which may or may not be normal. The second plot shows the sampling distribution of the sample mean, which is constructed by repeatedly drawing samples and computing their mean. Now let's interpret what we observe. Even when the original population distribution is highly skewed or non-normal, the distribution of the sample mean gradually becomes more symmetric and bell-shaped as we increase the number of samples. This is the key idea behind the central limit theorem. We can also observe the effect of the sample size. When the sample size is small, the sampling distribution may still show some irregularity. But as the sample size increases, the distribution becomes more stable and increasingly normal. So through this interactive visualization, we can clearly see how the central limit theorem works in practice, transforming any population distribution into approximately normal sampling distribution of the sample mean. Overall, this Shiny application provides a powerful and intuitive way to understand one of the most fundamental concepts in statistics. Thank you for watching.